Hi, my name is Samuel Garcia. I am currently in EEE 120, Digital Design Fundamentals, taught by Dr. Ayesha Ahmed. This is going to be Lab 0, and the date is January 19th, 2025. Okay, so I'm going to go through and present the Lab 0 project where we briefly build a 2-input XOR gate using AND or NOT gates in digital. And then we simulate it. And finally, we export the design to Verilog. And I'm going to be explaining each one of those steps for the project. So first is the digital design. This is going to be the digital design. Let me make sure I got my right. Let me put it right here. So what is going on in this digital design? What we did is using NOT and OR gates, we simulated an XOR gate function, okay? And what is an XOR gate function? An XOR gate function is when when a requirement for the XOR gate to output an ON, only one of the inputs has to be on. Meaning if there are two inputs, then if one is on, then the other is off, right? When both are off, the output is off, and when both are on, the output is off, okay? So that's what we had to do, and that's what we did using NOT and OR gates, because these three are fundamental gates. We can make any design with these three gates, okay? So let me explain how this process works. So we have A, and we're going to follow along, and B, and we're going to follow along, and we're going to follow along the four potential combinations. So the first combination, right, let me start the simulation, is going to be off and off, right? So first let's see what's happening with A. So A is off. If we go to the top, we can see that there's a NOT. That NOT turns it on. This is an AND gate. A requirement about the AND gate is that both inputs have to be on in order for an output to be on. So it's going to output off. And the reason is B is also off. So even though the NOT is on for A, the B output is off, and there's only on and off, resulting in off, right? Let's go over down to here, right? Let's follow along the B. Same thing with the off over here, but over here, we also have a NOT connected to a second AND gate that is going on. But the same thing that's happening with the first AND is happening with the second, where A is off, and so the AND is off. Now, because both the first and the second AND gate are off, the OR gate does not trigger, resulting in an output of an off, okay? Now let's go to the second simulation. B is on, A is off. What's happening here? So, because B is on and is connected to this first AND gate, the output is on, right? A is off, but it has a NOT gate, so it goes to on, resulting in input 1 and input 2 being on, causing the AND gate to go on. Now, the OR gate functions where if a minimum of one input is on, then the output would always be on, resulting in Y being on. All right, let's go to the second combination. So we're going to turn off the B, we're going to turn on the A, and we're going to see the same thing. We are going to see that A is on, resulting in the second AND gate being on. The second AND gate being on is because the B gate is off, resulting in the NOT gate to turn on. And because that second AND gate is on, it goes to the OR, resulting in an output of 1. The last combination, A on, B off, the output is off. Why is the output off? The output is off because both NOT gates are off, resulting in neither of the first or the second AND gate from turning on. And because both of them are off, the OR gate doesn't trigger, resulting in an off output. So that's how the simulation on digital works, right? So I'm going to stop the simulation. And now we're going to export it and simulate it in Wave through Verilog, right? So as you can see here, we exported this design into Verilog. Verilog now demonstrates the off and the on option, right? And what we see is the same thing, right? So for A, there's on and then there's off, resulting in the light green being on and the dark green being off, right? As we can see here, the output of Y is only on when B is on, A is off, or B is off, A is on. If both A and B are on, it is off, and if both A and B are off, Y is off. And so we can see that in both the Verilog and in the digital design schematic, we have made an XOR function using NOT and OR gates.